This video is just to give an example of how scripts work in the robot app. So here I have a robot arm that's connected to the three main PCBs, the ETH switch, the ETH motors, and the ETH accels, and then also a regulator which provides 3 volts, 3.3 volts to all three PCBs. And they're being run off of a battery. So there's an Ethernet connection to the switch for both PCBs. They're all connected to the Ethernet. So the brain that's running this is this computer over here. And the only connection that went underneath there, it's basically like a mini ATX Intel Celeron, just a computer basically, PC. The only thing that connects this brain to this arm, is a Ethernet cord, like a much of an Ethernet cord. One cord connected, 3 cords connected as one. This yellow cord. That's the only connection. No power connection between the brain and these electronics in this arm. That's the only connection. So I have an accelerometer that I have mounted on this arm. It has just one motor and it's fastened to a table here with this clamp. So here we have our 3 windows, actually 4 windows of the robot app. The main window here, the accelerometer window, and then the motors. So here I'm already getting samples from this one accelerometer. You can see it as an X angle of -7 degrees. That's where that arm is. X is in the direction towards the door, basically. So, okay, so here's a script, just a robot arm 01SH. All it does is starts logging, it logs all the accelerometer data and gyroscope data. It's just saying, is just saying use the script name in the log, so you know when you're opening the log in the file name what script that log is to. Then we're just storing the left angle. This is the lower left. It's basically viewing this currently as the lower left X angle. In the future I'm going to make this so you can really name any accelerometer anything you want, but for now I'm just calling it accel left lower leg. So we're just storing that X angle for later use. I don't happen to use it in this script, but I just wanted to show you that that's possible. You can then later use that to say go back to your original angle. In fact, I can use that here. Okay, so first, just one instruction at time 0 milliseconds. Have this motor left foot. You can later call it like robotic motor, robot arm, or something. You know, I'm going to add that functionality. Speed of 20. That's the maximum speed. Because this is 12 volts, it's kind of slow. I can actually do the full 20 speed. 20 is the top speed currently. Gives it a timeout of 8 seconds. Basically, to use this accelerometer, so lower left leg, the X dimension of it, there's X, Y, Z, right? When that reaches 40 degrees, it's right now at -7, -1 or +1, then that's the target angle. So go there. Okay, so now I'm going to load the script in the tasks window. I've already loaded it, so I'm just going to reload it here. The script is reloaded. Now I'm just going to run it. And it's just going to angle 40 with a timeout of 8 seconds. Timeout is important. So that's 40 degrees in the X. And we can confirm this by looking at the, it's about 42. It got pretty close to it, but it went a little bit over. So one thing to note is that we will not see the data when the script is running because it's a little too much for the computer to be processing samples and also drawing them to the screen, 100 samples per second. So basically, you know, it sort of stops showing the data while it's running it. So that worked. So let's say, okay, 8 seconds later after that first one, let's send it back to, let me uncomment this line. Let's send it back to 20 degrees. and then 12 seconds, let's send it, continue to send it that way to minus 10 degrees. And then this command also, at 12 seconds, just stop logging at that point. So now let's reload our script, robot arm, and run it. So it should go to, from 42 to 40, it will not have to go far then, to 20, and then to minus 10. So it's going to be going up. Basically, 0 is vertical, right? 0 degrees. So let's take a look at what happens. Run. So it doesn't really move. It's already within its range there. So it should be running pretty soon here. Yeah, here it's going up to 20 degrees and then minus 10. And that's in real time. We can look at the logs and see that it did in fact do those things in real time. So now when I run the script again though, watch what happens. It's going to go to 40 degrees. Here it didn't quite get to minus 10, it got to minus 6 or minus 7 basically. So now when I run it, it's going to go all the way to 40. It needs to go a long distance. So here, let me run it again. Here it goes to 40. Okay, it's waiting until 8 seconds, up to 20, until 12 seconds, up to minus 10. This is not on a real-time computer. That's another thing I should mention. This is not running real-time. You should run RT preempt. This kernel is not a real-time kernel, but yet it still works, which is really interesting. I probably should be doing this on a kernel that has the RT preempt enabled. So that's really interesting. But if I wanted to go back to its original angle, wherever it started from, I could add that here. Instead of minus 10, I could just put LLL x0, this variable I assign that initial angle to. So if it's minus 3, then this will go back to that angle. Let's make sure that does it. Let me reload the script and then run it. So it's going to go back to whatever its starting angle is, which is, if I get my neurons, minus 3 currently. So it should go back to minus 3 all the way up, almost vertically, if this code works correctly, which it should. So first it's going to go down to 40. Then up to 20, and now will it go to minus 3? Let's see where it ended up. Up minus 4. It went a little bit over, but that's basically close. You can see that it pretty much, that code does work. So that's just a little quick example with this robot arm. Again, just one cable connects the brain to this thing. Now, if I want to change brains, I can do that really easily. I can use this nuke and run it in real time. That has a real-time OS on it. It has a real-time preempt Linux configured on it. So just pull out this, plug in the other one, and you have a totally different brain, for this body, basically.